Hello, 1, 2. Hello, 1, 2. Statistics is the study of how to collect data, analyze the data, and draw conclusions from your data set. So you can use statistics to answer questions like what is the likelihood of someone purchasing your products, or how many calls will your support team receive in your organization. You can also use it to calculate something like how many gene size should you manufacture for all your customer based on past sales or data sets you have in your inventory. So welcome back to the channel. Welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 40. We are 40% out of 100 days. So we are on a new course called Introduction to Statistics in Python. So this career track actually contains 9 courses. So in all of those 9 courses, there are some projects, or probably like 4 projects that we have to work with. So we are on the 7th course called Introduction to Statistics, where we'll be learning all about summary statistics. We'll be learning all about random numbers and probability. We'll be learning all about distribution and central limit theorem. We'll also look into correlation and experimental design. So those are the 4 chapters we'll be looking at. So we're starting with the first chapter, which is summary statistics. So it gives us the ability to explore some statistics like a mean, median, standard deviation. And we're going to learn how to accurately interpret all these some statistic terms, which is mean, median, and standard deviation, and all other statistics that we can come up with. So welcome back to the channel. So without further ado, without further delay, let's jump back to learning. So if you're looking to upskill yourself with Python, you want to start from the very basics, which is Python day one, where we got introduced to Python variables or pandas, lists, matplotlib, and all other Python stuff that we've done. So I encourage you to go to the live stream tab on Excel Island YouTube channel. Just go to the live stream tab and look for Python day one. You just have to scroll down a little bit. You're going to get it and see from Python day one, where you get to what? Explore your analytical skills in Python also. So if I just start sharing my screen real quick, so I'll show you what we need to work with. So the data set we'll be using for this data analysis in Python, we'll just be looking at this meal deals. This is the sales data, this food consumption data, and the world happiness data. So I'll make this data set available in the link under the YouTube description, so you can also practice your summary statistics skills also. You can see I just downloaded the data set just like a few hours, 51 minutes ago, while preparing for the live stream. So I'll just go back here and we go to data analyst in Python, so we can continue from there. So we've started from introduction to Python all the way to intermediate Python. We did a little bit of project with this investigating Netflix movie. I have the code solution to this project on day one of the days in the live stream. We also did data manipulation. We will move to this second project, which is exploring New York Public School test results scores in Python. We answered some key questions in the analysis. Then the last one was journey data with pandas, where we actually looked at how to merge and combine multiple data sources into one single master sheet in Python. So we are now moving to introduction to statistics in Python, where we go your statistical skills and learn how to collect, analyze, and draw accurate conclusion from data using Python. So as usual, we have 4 chapters to tackle. So let's just start immediately and see what we need to learn today. So the goal is to learn just for 1 hour daily. After learning as a freelancer, I just get to learn and upskill myself. And by the end of the day, I work on client projects and look for job also. So let's start immediately without.
Hi, and welcome to the course. My name is Maggie, and I'll be your host as we dive into the world of statistics. So, what is statistics anyway? We can talk about the field of statistics, which is the practice and study of collecting and analyzing data. We can also talk about a summary statistic, which is a fact about or summary of some data, like an average or a count. A more important question, however, is what can statistics do? With the power of statistics, we can answer tons of different questions like, how likely is someone to purchase a product? Are people more likely to purchase it if they can use a different payment system? How many occupants will your hotel have? How can you optimize occupancy? How many sizes of jeans need to be manufactured so that they can fit 95% of the population? Should the same number of each size be produced? A question like, which ad is more effective in getting people to purchase a product, can be answered with A/B testing. While statistics can answer a lot of questions, it's important to note that statistics can't answer every question. If we want to know why the TV series Game of Thrones is so popular, we could ask everyone why they like it, but they may lie or leave out reasons. We can see if series with more violent scenes attract more viewers, but even if they do, we can't know if the violence in Game of Thrones is the reason for its popularity, or if other factors are driving its popularity, and it just happens to be violent. There are two main branches of statistics: descriptive statistics and inferential statistics. Descriptive statistics focuses on describing and summarizing the data at hand. After asking 4 friends how they get to work, we can see that 50% of them drive to work, 25% ride the bus, and 25% bike. These are examples of descriptive statistics. Inferential statistics uses the data at hand, which is called sample data, to make inferences about a larger population. We could use inferential statistics to figure out what percent of people drive to work based on our sample data. There are two main types of data. Numeric or quantitative data is made up of numeric values. Categorical or qualitative data is made up of values that belong to distinct groups. It's important to note that these aren't the only two types of data that exist. There are others too, but we'll be focusing on these two. Numeric data can be further separated into continuous and discrete data. Continuous numeric data is often quantities that can be measured, like speed or time. Discrete numeric data is usually count data, like number of pets or number of packages shipped. Categorical data can be nominal or ordinal. Nominal categorical data is made up of categories with no inherent ordering, like marriage status or country of residence. Ordinal categorical data has an inherent order, like a survey question where you need to indicate the degree to which you agree with a statement. Sometimes, categorical variables are represented using numbers. Married and unmarried can be represented using 1 and 0, or an agreement scale could be represented with numbers 1 through 5. However, it's important to note that this doesn't necessarily make them numeric variables. Being able to identify data types is important, since the type of data you're working with will dictate what kinds of summary statistics and visualizations make sense for your data, so this is an important skill to master. For numerical data, we can use summary statistics like mean and plots like scatter plots, but these don't make a ton of sense for categorical data. Similarly, things like counts and bar plots don't make much sense for numeric data. Time to master these important skills.
Okay, interesting. So let's see what we need to learn or solve in this summary statistics. So we know that there are two different types of statistics, which is descriptive statistics and inferential statistics. So statistics can be used to answer lots of different types of questions, but being able to identify which type of statistics is essential to drawing accurate conclusions. So in this exercise, you will sharpen your skills by identifying which type is needed to answer each question. So identify which questions can be answered with either descriptive statistics and which question can be answered with inferential statistics. So this one says, giving data on every customer service request made. Okay, let me read this again. Giving data on every customer service request made, what's the average time it took? The average time it took. The average time. Mm, okay. That's definitely descriptive. Let's see. After interviewing 100 customers, what percentage of all your customers are satisfied with your? That is definitely influential. We're going to use percentage, a sample out of 100 customers. Give me data on 20 fish caught in a lake. What's the average weight of all fishes in the lake? Hmm. I'll go for descriptive because if you're looking at the average, we're going to pick, we're trying to summarize the data. We're trying to describe and summarize the data set. Giving data on all 100,000 people who view an ad, what percent of people, let me see, what percent of people click on it? Hmm, okay, let's log that in. Ooh, I missed it to each other. So I think that if I have data on over 100,000 people who viewed an ad, I want to know the percent of people. Okay, that will be summarized. Okay. Giving data on 20 fish caught in a lake. What's the average weight of all the fishes in the lake? Oh, average. You just see inference statistics. So we missed that there. So it's nice work. Knowing the type of statistics you need to answer your question will help you choose the appropriate method to get the most accurate answer possible. That's interesting. So I need to know which statistics to use. Okay. Data type classification. We know there are continuous numeric, discrete numeric, and categorical. So in the video, you learned about so many types of data, numeric and categorical. So numeric variables can be classified as either discrete or continuous. Okay. And categorical variables can be classified as either nominal or ordinal. So these characteristics of a variable determine which ways of summarizing your data will work best. So zip code. Hmm. Zip code can be measured. You can't do any analysis on zip code. It's just an information. It's specifically used for mapping. Zip code is normally used in mapping. Okay. Hmm. Let's go for categorical. Kilowatt of electricity used. So it can always continue. So be continuous because it can always change. Number of DataCamp calls taken. Let's go for discrete counted. Brand of a product. Let's go for this. Air temperature is continuous. Air temperature can be continuous. Number of items in stock. Number of items in stock. Hmm. It should be discrete. Let's see. Ooh. Oh, wait, brand of a product. Now, oh, brand of a product is categorical. Why do I miss that? Since brands, so it can be Gucci or Versace and various brands like that. Interesting. So perhaps certain skills. So these skills will be important when it comes to choosing summary statistics and visualization. Okay. So we learned for the past 40 days. So measure of central tendency. And that is mean. That is mean, median, and mode. Here it's like measure of central tendency. That is mean. Let's see.
In this lesson, we'll begin to discuss summary statistics, some of which you may already be familiar with, like mean and median. In this video, we'll look at data about different mammals' sleep habits. Before we dive in, let's remind ourselves how histograms work. A histogram takes a bunch of data points and separates them into bins, or ranges of values. Here, there's a bin for 0 to 2 hours, 2 to 4 hours, and so on. The heights of the bars represent the number of data points that fall into that bin. So there's one mammal in the dataset that sleeps between 0 to 2 hours, and 9 mammals that sleep 2 to 4 hours. Histograms are a great way to visually summarize the data, but we can use numerical summary statistics to summarize even further. One way we could summarize the data is by answering the question, how long do mammals in this dataset typically sleep? To answer this, we need to figure out what the typical or center value of the data is. We'll discuss 3 different definitions or measures of center: mean, median, and mode. The mean, often called the average, is one of the most common ways of summarizing data. To calculate mean, we add up all the numbers of interest and divide by the total number of data points, which is 83 here. This gives us 10.43 hours of sleep. In Python, we can use NumPy's mean function, passing it the variable of interest. Another measure of center is the median. The median is the value where 50% of the data is lower than it, and 50% of the data is higher. We can calculate this by sorting all the data points and taking the middle one, which would be index 41 in this case. This gives us a median of 10.1 hours of sleep. In Python, we can use np.median to do the calculations for us. The mode is the most frequent value in the data. If we count how many occurrences there are of each sleep total and sort in descending order, there are 4 mammals that sleep for 12.5 hours, so this is the mode. The mode of the vor variable, which indicates the animal's diet, is herbivore. We can also find the mode using the mode function from the statistics module. Mode is often used for categorical variables, since categorical variables can be unordered and often don't have an inherent numerical representation. Now that we have lots of ways to measure center, how do we know which one to use? Let's look at an example. Here, we have all of the insectivores in the dataset. We get a mean sleep time of 16.5 hours and a median sleep time of 18.9 hours. Now let's say we've discovered a new mystery insectivore that never sleeps. If we take the mean and median again, we get different results. The mean went down by more than 3 hours, while the median changed by less than an hour. This is because the mean is much more sensitive to extreme values than the median. Since the mean is more sensitive to extreme values, it works better for symmetrical data like this. Notice that the mean in black and median in red are quite close. However, if the data is skewed, meaning it's not symmetrical, like this, median is usually better to use. In this histogram, the data is piled up on the right with a tail on the left. Data that looks like this is called left-skewed data. When data is piled up on the left with a tail on the right, it's right-skewed. When data is skewed, the mean and median are different. The mean is pulled in the direction of the skew, so it's lower than the median on the left-skewed data and higher than the median on the right-skewed data. Because the mean is pulled around by the extreme values, it's better to use the median since it's less affected by outliers. Let's practice using measures of center.
Oops. Interesting. So we know measure of center is the mean, median, and mode. Okay. So to work with statistics in Python, you're going to be using the NumPy array. So far we learned all about the pandas array, the matplotlib. Let me just connect my power source there. So in this chapter, you'll be working with the food consumption data set from 2018 Food Carbon Footprint Index by NU3. Oh, good news, we have access to the data set, consumption data set. I'll leave the data set under the YouTube description. There'll be a link to the data set so you can download and practice also. Okay, so the food consumption data set contains number of kilograms of food consumed by a person per year in each country and food category, consumption, and its carbon footprint, which is the CO2 emission column. So you have 2 columns here, measured in kilograms of carbon dioxide or CO2. So in this exercise, you compute measures of center to compare food consumption in the US and Belgium using your pandas and NumPy skills. So pandas is imported as PD for you and food consumption is preloaded. So let's do that also in my local machine here. I'll just create a new Jupyter notebook. Uh-oh. I think we're going to continue this part of the lesson tomorrow on day 41. That's because my source of power is giving me sign already. So I'm just going to continue from here on day 41. I'm going to continue from here on day 41. My my power source is low. My inverter is low. My backup is low. I just have to show up today just for a few minutes, so I won't miss a day. So we continue from here. So we've learned all about what descriptive and inferential statistics are. We know data type based on classification. So definitely we'll just complete the main median, answer the questions. We'll complete this chapter one or tomorrow, which is with day 41. All right, so that'll be the end of the live stream for today. I hope you enjoyed the little session we had today, and I'll see you on day 41 so we can continue and start analyzing both in the environment provided on the platform and on Jupyter Notebook. I'll leave a link to the data set so you can join me and practice also tomorrow. Do have a wonderful rest of the day. Bye for now.